Hi Year 7s. Well, in my absence today, what you'll do is look at tables and rules. And you'll have this set of notes that you need to annotate as this video goes. And then just pop these into your notes book as well. Now, this particular exercise is a kind of preparation task, I suppose, in the lead up to the task that's coming up in a couple of weeks' time, which I'll talk a little bit more about. But that one will be done under assessment conditions. But what it will do is use a similar set of skills that you're going to use today. So today's going to be good practice for you. All right, so what is a rule? A rule is a link between an input and an output. And what does that mean? Let's have a look at some examples here. So we've got these inputs. All right, so you can see here we've got a table. This is called a table of values here, this thing here. And what we've got is a bunch of inputs. All right, and what we want to know is what's the output if the input is 3? What's the output if the input is 5? What's the output if the input is 7, and so forth. So we can see here that we really don't know what the output's going to be unless they give us the rule, and this is what the rule is. Okay, so they're saying the output is the same as the input number take away 2. All right, so we can see here that the input number is 3. So we're going to remove 2 from the input number, and that'll be the same as the output number. So 3 take away 2 is 1. So if the input number is 3, then the output number is 1, because we're removing 2 from the input number. Right, now we'll do 5. So we're going to do 5 as the input. 5 remove 2 is 3. If 7 is the input, 7 take away 2 is 5. Okay, and if the input is 12, 12 take away 2 is 10. Finally, if the input is 20, 20 take away 2 is 18. Okay, so if these are the input numbers, these will be the output numbers for this rule here. All right, let's have a little bit more of we'll go to a little bit more of a complicated example. So here the rule is a little bit more complicated, but we use the same process. So if the input is 4, we do 3 times the input number, which is 4. So 3 times 4 is 12. 12 plus 1 is 13. So on an input of 4, 13 will be the output. All right, let's try 2. 3 times the input, which in this case is 2. So 3 times 2 is 6. 6 plus 1 is 7. All right, 9. 3 times 9, know your times tables here. 3 times 9 is 27. 27 plus 1 is 28. All right, now 12. 3 12s are 36. 36 plus 1 is 37. Let's finish with 0. 3 lots of 0 is 0. 0 plus 1 is 1. Okay, so what you can see here is that we've been using the rule to complete the table of values. Now, there's a scenario where we get given the table of values, but we don't have a rule. And what we'll be asked to do is to find the rule. So you could use a bit of trial and error, but I'm going to show you a technique that you're going to use a lot over the next few years to try and find the rule for these types of scenarios. So we can see here when the input is 3, the output is 12. When the input is 4, the output is 13, etc., etc. All right, so what you want to do is you want to find, as these numbers go up by 1, you want to look at what is the change in these numbers, or at what rate does this go up or down when these go up by 1. So you notice that it's up by 1. When this goes up by 1, this also goes up by 1. When this goes up by 1, this one also goes up by 1. And it's going to be the same process for each of these input numbers. All right. Now, what that tells us is the output. So we're going to start writing our rule. Output is the same as the input. Okay, so the input times 1. Okay, now why did I multiply by 1? Because it's always whatever the output goes up by each time. So if it's going up by 1, it's changing by 1 each time. Okay, so it's going to be the input multiplied by 1 plus or minus a certain value. Now, how are we going to work out what that value is going to be? Well, if we multiply the input number by 1, so we do 3 times 1, that's going to be 3. Now what needs to be added to 3 to get to 12? Well, I think that's 9. So we're going to say it's plus 9. So here is my proposed rule. All right, and I'm not sure whether it works. Let's try it out. So all I'm going to do is take the next input, which is 4, all right, and say 4 times 1 is 4. 4 plus 9 is 13. So it works for that one. And if you've checked it for 2 of these scenarios, then you know it's going to be the same. It's going to work for all of the other values. But let's do 7 anyway. 7 times 1 is 7. 7 plus 9 is 16. So it works for this one as well. Okay. So again, to summarize, all we do is we look as this goes up by 1, what does the output go up or down by? Okay, and we write that in here. That's going to be the times whatever that amount is. And then we look at, well, what would I need to either add or subtract to the input to get it to the output? All right, let's try the next example. So we can see here as this goes up by 1, this goes up by 7. So we can now write our rule. Output equals the input times 7, all right? And then all we do is we look at, okay, if we times the input by 7, what do we need to add? Well, we can see here we actually don't need to add anything. Plus 0 would be what it is. And let's just check it. 2 times 7 is 14. 3 times 7 is 21, etc., etc. So this is actually our rule, and we don't need to add anything to it. That's going to be fine. Okay, so the last scenario is that we are given a pattern or a diagram and need to make both a table of values and then find the rule. Okay, so here we go. We've got the number of tiles required to pave around a spa is related to the size of the spa. Right, so we're assuming that this thing here is the spa. Okay, and if this is the spa, this sort of shaded tile here, then we can see that we are going to need 1, 2, 3, 4, 5, 6, 7, 8 tiles around it. Okay, so we can see here that a spa of length 1 unit requires 8 tiles. 1 unit, 8 tiles. Now we can see that 2 units is going to require 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tiles. Now we can see here 3 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 3 requires 12. Okay. Alright, so let's start answering some of the questions. Complete a table of values relating length of spa and number of tiles required for values up to and including a spa of 6 units. Okay, so we know that, let's write tiles. Actually, let's write unit length and tiles. All right, now the possible unit lengths, well, we've got 1 unit there, we've got 2 units, 3 units, 4 units, and these guys want us to go up to, what was it? 6 units, this one here. So we've got 5 units, and then we've got 6 units. So there's our table of values. I'm just going to make that look a little bit nicer. Okay, so we know some of these already. We know that for a spa of unit length 1, it takes 8 tiles around it. 2 is 10. 3 is 12. Now 4, can you predict what it's going to be? Well, you can see here that it's going up by 2 each time, which makes sense because every time we add one of the tiles, we add 1, 2 tiles around it. Okay, so spa increases by 1 means that there's 2 more tiles. So this makes perfect sense that 4 will be 14, 5 will be 16, and 6 will be 18 tiles. We don't need to draw it to work this out. Alright, now we're going to describe a rule that connects the number of tiles required for the length of the spar. So we're going to say that tiles is equal to or the same as. Alright, now remember, as this goes up by 1, this goes up by 2. So that's going to be the unit length times 2. We double the unit length. Okay. Now, if we do that, 1 times 2 is 2. Now we've got to work out how many we need to add to get to 8. And I think the answer is 6. Alright, now we can try it. So we're going to go to unit length 2 and go 2 times 2 is 4. 4 plus 6 indeed does equal 10. So the rule works, and we just need to check it twice, and we assume then that it works for the rest of the items, because it will. Okay, the largest spar made is 15 units long. How many tiles would be required to pave around its perimeter? So we don't draw this one. We don't need to draw a 15 unit spar and count tiles because we've got this rule. Okay, so we're going to use the rule. So we're going to say tiles equals the unit length, which in this case is 15, times 2 plus 6. Now 15 times 2 is 30, plus 6 is 36 tiles. Alright, a paving company only has 30 tiles left. What is the largest spar they could tile around? Okay, so we can see here that 6 units, okay, 15 units requires 36 tiles. So what I'm going to do is try 14 units and just see what happens. Just one less, because this is going to be 36, and I suspect we might get it right if we do 14. Let's just see how we go. So I'm going to say tiles equals 14 times 2 plus 6. Now that's 28 plus 6 is 34. This doesn't work. Okay, so that would use 34 tiles. So we can see that 14 units would require 34 tiles. 15 units required 36 tiles. So why don't we go and summarize this? So 14 units is 34. What do you reckon 13 units will be? Well, that's going to be 32. 12 units is going to be 30. And that's what we're after. So the largest spar that they could tile around is 12 units. Okay, so from here you're going to try this out yourself. Now, this is the work here. Making sure that we know that we're now moving from chapter 10 back to chapter 3. Okay, so we're not in equations anymore. We need to go back to chapter 3. We're going to do 3K. These questions here. Actually, don't do question 6, because that's the one I just used as an example. Okay, so 3, 4, 5, and 7. And then these table of values questions 1, 3, 5, and 9. Good luck, guys.